Hello and welcome to Technical Drawing Solution. I'm DN Kamau. Today I'm going to take you through drawing a cross section through a building, and this would involve cutting through this section of a plan and drawing this cross section over here. Before we go into answering the question, let us look at some of the terminologies that we may meet along the way. So here we have a front elevation. This is simply an orthographic view of the front of that building. Then we have the end elevation. This shows the side view of the same building. And if you look at this, here we have the cross section XX. We have the section YY. And then here we have the plan together with the specifications. These specifications are the ones that help us to draw this cross section. So the question here reads, Figure 3 shows a plan. There's nothing here. Here there is nothing. So actually we are going to start from the strip foundation, and the strip foundation is 900 millimeters below the ground level. Then that is the first thing we are going to draw. We're going to draw the level of the ground level of the foundation, yes, and measure the 900 millimeters so that we reach the ground level. And therefore that will basically give us the starting point. Then we shall, after placing our foundation, then do the foundation wall on top of the foundation, and then the floor slab on top of the foundation wall. Then from that level, then we can come down and get the blinding, and then place the wall above the floor, which is the superstructure. Then measure 2100 millimeters to reach the ring beam, yes, the bottom of the ring beam. And since we have been given the 300 as the depth of the ring beam, then we can measure from 2100, we can measure 300 going upwards, and we shall be able to get the ring beam in place. And then we have the floor to ceiling height. That will give us the wall plate level, yes, and once we reach the wall plate level, we can place our wall plate and then have our roof pitch at 30 degrees being given the rafters. So assume any other information not given. There's a lot of information that has not been given here. For example, the strip foundation size has not been given, hardcore size has not been given, height of the ring beam has not been given, the window details have not been given, the rafter has not been given, the purlin has been given but the rafter is missing. We also don't have the fascia board. So all that you have to assume. So there's a lot of information that we need to assume here. So basically this is the plan, but what we really need is this portion over here. This portion here shows that we are cutting through a wall, and we are cutting through a wall which also has a window, and this is a window sill. So things to do with the window, we shall have to assume a lot there. And I think with this information, then we can go ahead and start.
So let us look at a metric scale that measures in millimeters and meters. That is the scale that we are going to use. And this is an example of a scale rule. So our scale rule here, we can see there is 1:2, 1:20, meaning that 1:2 will give us a half scale, so that 10 millimeters would appear as if it is 5 millimeters, and so on. So let's look at 1:1, because it is the full scale. Notice that this scale has 12 different scales. So here we have 1:1, and this is called the full scale. So in the full scale, it measures like the ruler. 10 millimeters would stand for 10 millimeters. But notice that a scale of 1:10, for 10 millimeters, it would be measuring 100 millimeters. So the scale is graduated into millimeters and meters, and we have all these scales from 1:1, 1:2, 1:5, and so on. This is called a builder scale, since it measures around about up to 2,500, 1:2,500, which is almost a map scale. A builder would normally use from about 500 going downwards up to 1:1. So for the work that we are going to do, we have been given a scale of 1:20. So let's look for 1:20. And 1:20 will be right. 1:20 will be here 20, and we want to measure 600. So you can see that there are two graduations. On top we have 1:2, and at the bottom we have 1:20. So we can measure two different scales, 1:20 and 1:2. So for 1:2, you would always read the upper scale, and 1:20 you would read the lower scale. So for us to measure this line here, then we shall place our scale right there, and you can see that is 600 millimeters. 600 millimeters. So whatever scale you read, you will just measure it directly like that. And on this side, that scale there, and that will be 200 millimeters. Or if you are reading 1:20, then that would be 20 millimeters. So where we don't have a scale rule and we would like to measure 600 and 200, and we have been given a scale of 1:20. So what do? We take 1/20 times 600. So that goes with this, and this 2 goes here, 30, and therefore this gives us 30 millimeters. So we would just take our normal ruler and then measure 30, because a scale of 1:20, a scale of 1:20, in real sense, when you are measuring 600, you are actually measuring 30 millimeters in
This diagram shows how the question should be answered. You can see that we have, for foundation down here, the foundation right there, and then the foundation wall. We have hardcore, blinding. There is the floor, concrete. Then there is superstructure wall, and then the ceiling height. Ceiling height is about there, 2500, and then 2100. That is the ring beam height. Then we have the eave here as 600, and so on. Looking at it more closely, then we would pick up this part like that, and then we are able now to see that the foundation is 600 by 200, and this is 600 by 200 concrete strip foundation. Then we have 200 millimeters stone foundation. You can see the hatching here is for stone and the hatching here is for concrete. Then from there we have the hardcore, and before that, because this is what helps us to get to the ground level, that is the height or the depth from the foundation to the floor or the ground level. Yeah, so it's called the depth of the foundation. So with the depth of the foundation, you are able to measure and get to the ground level, and then from there, then we can place our floor there, and the floor is 150 millimeters. So that is also incidentally the DPC level. Therefore, you can get that level of the floor using that, and then measure downwards, get the DPM, the blinding. Then we have the DPM just in that line there, and then 150, 1:3:6 mass concrete floor slab, and then basically we move on to the superstructure up to the window sill level. But to get the window sill level, you first have to get the 2100 height. This 2100 height, you have to get it first, which is from the floor level up to the bottom of the lintel or ring beam. So once you get there, then you can measure 1200 from under the ring beam to that level of the window. Then you can put your window sill there, window sill 50 millimeters by 25, and then with that slope like that, and then we have that window frame, yeah, the window frame and the shutters, window shutters there, all the way up there. Then the ring beam is 300 by 200 there, and then we reach the ceiling level. That's where we place our wall plate, which is 100 by, supposed to be 75, mistake there, supposed to be 75, and then you place that rafter line, and you measure this 100 perpendicular to that rafter, so that's 100 millimeters, and then you place the next rafter lane to make that rafter. So then you can measure this 600 to stop the rafter over there, and you place your fascia board, which is 250 by 25, not given. Most of the things we have done here is by assumption, since we're told to assume anything that has not been given. Therefore, basically that is it, and we shall now try to do it step by step. So the first thing to draw here is the foundation, and since it is the lowest part of the building, then we need to draw it right from the borderline. Just leave a small margin from the borderline, the bottom borderline, and draw 600 by 200 to a scale of 1:20. Therefore, if we are drawing to a scale of 1:20, then we have to divide everything, we have to multiply everything by 1/20, by 1/20. And therefore, if we were to multiply 600 by 1 is over 1/20, then we would get this as 30, and this as 30, and so on and so forth. So measure 30 millimeters to represent 600, and measure whatever represents 200, and with that rectangle, then we can continue to measure the foundation depth. So to place the foundation floor, because we've been told foundation floor is 200 millimeters stone wall, then the best way to do it is to get the center of this, which is half of this 600. At 300 there, you measure 100 on one side and 100 on the other side. Remember, we are using a scale rule, and if you have a scale rule, you just need to check the scale of 1:20, and you will measure directly as has been given. So after you've measured the center and 100 on this side, 100 on that side, then you can raise those lines representing the floor, and we have to measure from this level 900 so as to terminate this wall. So at 900, then we can terminate the wall, and therefore now we have the foundation there ready, and the wall, the foundation wall, up to that level. And since this is now our ground level, then it means from the ground level to the DPC level is always 150 millimeters. Incidentally, we have also been given the floor as 150. So the next thing is really to place the floor on top of this foundation wall. So that's our floor there, and notice this part that shows continuity, because we cannot draw the full wall, and therefore we put this continuity line. And hatching is also a very important part of this drawing. This hatching here shows concrete, and this one here shows the stone wall. This one here shows the hardcore, and there is missing hatching for the blinding. The blinding is supposed to be small dots all through. I wasn't able to do that, but you should be able to do those dots here. And this also shows the concrete, and it also needs to have some dots after you've placed the ballast. Then you need to have those dots. So naming is also one of the things that you should not forget, although you can do it after you have finished the whole business. I just thought of doing the naming so that as we go along, we know whatever we are drawing. So the foundation itself here is 600 by 200 concrete steel foundation. Then we have 200 millimeters stone foundation wall. This is the substructure wall. Then we have 250 hardcore. How did we get into that? After reaching this 900 level, we did our floor, which is 150 mass concrete floor. And then we also placed 500 grade DPM right there. And from that level, notice that we measured 50 millimeters to get the blinding. That's a blinding. Then measure another 250 to get the 250 hardcore. Remember, this has not been given, and this has not also been given. And so those are some of the things that we are assuming. But the most important thing here is once you know the foundation depth, then you start from that depth and go to the ground level, and then you can measure every other thing in as far as the ground level is concerned. So once you reach the ground level, you can put your DPC at 150 from the ground level, and then measure the floor. If you are given a floor of 100 millimeters, then it would be floating somewhere here, and that would mean that the foundation wall would be exposed, a bit exposed from the ground level. But since we have been given 150 from the DPC level downwards to our floor depth, then the floor depth coincides with the ground level, and that now makes our business easy. Therefore, we can do the rest very easily. So once we have reached this level, then we can measure 2,500 to the ceiling level, because already we had done the substructure, and the superstructure wall is also 200 millimeters. So we only need to align it and take it up there and measure 2,500 and terminate it up there. We also have the the ring beam level, and the ring beam level is always 2100 millimeters from the floor level, and therefore we measure that 2100 millimeters, and since we have been given the ring beam depth as 300, then we can be able to place our ring beam comfortably there. Now from that ring beam 300 millimeters, you can hatch it, and then we have a window. And another assumption is that our window will be 1200. So you can see that this is an assumption, 2100 from the floor level to the ring beam bottom, and this is another assumption, 1200 from the bottom of the ring beam downwards. We can measure our window. So details of the window may not be required at this point, because the scale is too small to show all these details. But I've tried to show this since the software I'm using is able to allow me to do that. Now you can see that this is the window. We have the window sill here, and then the window frame and the window shutter there, and we have the window panes right here. And since that is not what we are interested in, we reach the ring beam, we hatch it, and I think that's good progress. Now on top of our 2500 millimeters height. On top of it, then we can have our wall plate. And the wall plate is also not given, that's an assumption. We shall have it as 100 by 75, supposed to be 75, but here it's been given by 76. I think that's typographical error. Then we have reached the wall plate level, and I mean at the wall plate level we are now going to the rafter, and the rafter angle we have been given as 30 degrees. So just place your ruler, T-square and ruler, T-square and set-square 30 degrees, and you'll be able to draw that line at 30 degrees. So after drawing that line at 30 degrees, then you need to draw another parallel line to it, which will also be 30 degrees, but 100 millimeters apart from this one. And it should be a parallel line, and it indicates the other line of the rafter. So how is it measured? You measure it perpendicularly to this line. So you make sure you measure it perpendicularly. Don't measure it vertical to the horizontal, but perpendicular to that one. Measure 100 millimeters and place the next line which is parallel to it. Place that line which is parallel to it, and therefore the rafter is complete. And the next thing is to measure the distance for the eaves here, so that we can terminate the rafter. So measure that 600 and terminate with a line, terminate that rafter. That's the position of the fascia board, position of the fascia board. So terminate it and place your purlins. The purlin is given as 100 by 50, and therefore place it standing. It's also supposed to be perpendicular to the rafter, therefore draw it in that manner, and then measure from one purlin to the next purlin 1000 millimeters. 1000 millimeters from one rafter to the next rafter, because we are going to use the roof GCI sheets as the roofing material, and we shall pick on 3 meters GCI sheet. So 3 meters GCI sheet can be placed conveniently within those purlins of 1000 millimeters center to center. So, and then you place your roofing material, and because it is a corrugation, we shall have one line on the purlin, and then measure 40 millimeters for corrugation to be able to get the second line. So after finishing the roofing material, should protrude a bit beyond the fascia board. You can now do the fascia board there, and the fascia board here will be 250 by 25 fascia board. You can place it correctly there, and basically you will have finished. So the next thing is now to make everything in finish line. So we can make now everything in finish line, and with the labeling that we have done, the work is complete and ready to be presented to the Kenya National Examination Council.